Are you ready to try the ionic bonding lab? You're going to need to either print out the worksheet by clicking the link and looking at the lab sheet, or open the link and do the lab on paper. So you'll need 3 sheets of paper to do the lab. Pause anytime you need to go slower or to get your supplies, and just resume when you're ready to go on. We're going to start with a short video. Play the video from your lab sheet, and when you're done, you can continue. In part 1, we're going to make a set of ionic bonding game cards. Again, you can draw these cards on paper, or you can use Google Drawing to add things to this worksheet. Or if you want, you can print out the worksheet and then work on it. You're going to, for each element, count the number of valence electrons. These are the electrons in the outermost shells. Use the number of valence electrons to draw an electron dot diagram, and you can refer back to the note slides to help you. You're going to put that in the bottom left corner of the card. Then you're going to determine the ion that the element will form. It's either going to form a +1, +2, -1, or -2 ion, and you'll write that on the card in the bottom right corner. We're going to start with lithium, and we'll do the same method for each card. First, ask yourself, how many valence electrons does lithium have? The outermost shell is called the valence shell, and we see that lithium has 1 valence electron. Now we're going to use that information to make the electron dot diagram for lithium. We start with the chemical symbol for lithium and place a dot for each valence electron. In this case, there's only 1 valence electron, so we'll put 1 dot. And then we're going to put that over here in the corner. Next, we're going to determine the lithium ion. Atoms are either going to lose or gain electrons when they form these chemical bonds for ionic compounds. Let's look at lithium. It has 1 valence electron. It is likely going to lose that 1 electron. It's easier to lose 1 electron than to gain 7 more to complete its octet. You might remember from our notes that the octet rule says that atoms are going to either try to gain, lose, or share electrons to have a complete set of 8 valence electrons. And it's going to lose 1 rather than gain 7. When it loses 1 electron, it's going to have more positive charge than negative charge. Remember that the protons in the nucleus have a positive charge. So 3 positive, and if it loses 1 electron, it will only have 2 negative. That will give it a +1 charge. Any positive ion we call a cation. So we're going to write Li1+. It's not like math class where the plus comes before the 1. On these ion diagrams, you're going to put the plus sign after the 1. Let's try the card for beryllium now. If you're doing these on paper, take your time, pause the video. You're going to need the name of the element, its chemical symbol, and the electron dot formula, and the ion. You can draw the Bohr model if you want, but you don't have to if you're doing them by hand on paper. So let's do beryllium now. How many valence electrons does beryllium have? Take a look at the diagram to find out. There's the valence shell, and you can see the 2 valence electrons in that shell. Remember that our electron dot diagram only shows the valence electrons. So although beryllium has 4 total electrons, we're only going to put its 2 valence electrons on our electron dot diagram. We'll add that to our card. Now we have to consider the ion that beryllium will form. It has 2 valence electrons, and it's easier to lose 2 electrons to achieve a full outer shell than it would be to gain 6 more. So it's going to lose 2 electrons. When it does that, it's going to become a positive 2 cation. If it loses 2, positive 2. If it loses 1, positive 1. So beryllium's going to lose 2, so it will have a positive 2. And we call that a cation, again, because it is positive. And cation is the word we use to mean positive ion. If you want, stop the video and try the next one on your own. Let's see how you did. For fluorine, there are 7 valence electrons. To draw the electron dot diagram, write the symbol, and now we have to add 7 valence electrons. Each side of the symbol gets 2 valence electrons total. You can't put more than 2 on a side. When you look at it, you can imagine an empty spot right here where another electron could go. That gives us a clue about the ion that's going to form. It's easier to gain 1 electron to achieve a full shell than it is to lose 7. So fluorine's going to gain 1 electron and become a -1 anion. We write it like this. We'll do one more together, and then you can try the rest on your own. Here's oxygen. Look at the diagram, the Bohr model, and see how many valence electrons oxygen has. Here's the valence shell, and we can count 6 valence electrons. Use that to draw the electron dot diagram. Start with O for oxygen, the chemical symbol for oxygen, and then we're going to add our 6 valence electrons. 1, 2, 3, 4, 5, 6. And write it on our sheet. And now determine the ion. It's easier to gain 2 more to achieve a full octet, the full outer shell, than it is to lose 6 valence electrons. Oxygen is going to gain 2 electrons and become a -2 anion. Anion, again, is the word we use when we're talking about negative ions. How did you do? Well, there are 4 more cards to complete. When you're ready, you can restart the video and we'll check those cards. Let's see how you did. There's sodium. The dot diagram has 1 valence electron, and the ion, once it loses that 1 valence electron, will be +1. Magnesium will have 2 dots on its diagram. and will form a positive 2 ion. Chlorine will have 7 dots for its 7 valence electrons, and it will have a negative 1 ion. Sulfur will have 6 dots on its symbol and form a negative 2 ion. We'll continue with part 2 at another time.